Hello, welcome to my video. Now, in this video, we are most definitely going to embark on this new topic, grade 10 physics, which is called waves, sound, and light. Now, this topic, it's a very interesting topic. Now, in order for you to understand everything that we're gonna learn under this topic, you need to visualize these things. You need to see them. I mean, like when you talk about the waves, you need to see these waves. When you talk about the sound, the light, think of the light. You understand what I'm saying? So now, before we can even start this wonderful topic, I just want to take you through this slide, uh, which is this one over here. Okay? I want you to watch this. Talking to them. Aha, I am sure you are most definitely wondering what was that slide all about. Now, what you saw over there, it's a snippet or a video of a wave. That's wave in water. So this topic actually talks about the waves. There are many different types of waves. Like for an example, we have the sound waves, we have the light waves, we have the electromagnetic waves, we have X-rays. Those are also regarded as waves. So there are many different types of waves, okay? But most definitely, we're going to start with the basics. We're going to learn how these actually waves starts, okay? Now, what are the characteristics? What are the components that leads to what we call a wave? That's what we are actually going to learn in this session. Now, without any further ado, let's just go through the basics. Now, before we can even think of a wave, we are going to build up to learn more about the wave. We have what we call wave, but we need to understand what forms wave. What is the source of wave? Where can we see wave? You understand what I'm saying? Now, in this slide over here, we have a term that is called a pulse. And we have a term that is also called a transverse pulse. But now let us learn what is a pulse. Now, a pulse, it is a single disturbance that moves through a medium. There is another term within this definition of a pulse, which is called a medium. But now, what is a medium? A medium could be anything, as long as that thing produces what we call a pulse. We're going to call that thing a medium. Now, to make things much more easier, here we have a rope, right? Or here we have it seems like it's a slinky. Here we have a slinky. Now, when you, what is this movement? When you move, when you, they say it's shank, right? When you shank your slinky only once, a pulse is gonna be formed on your medium. In that case, our medium, like I said, it's rope. So when you take your rope and shank it up and down just only once, what's gonna happen? You're gonna form or you're gonna propagate what we call a pulse on that medium. So a pulse is mountain-like structure, which is something that looks like this. But how does this pulse actually result on our medium? We are talking about a single disturbance. Now, when you have a look at this picture over here, we can see that a pulse has been formed on our medium. And a pulse, it is actually attaining a direction which is most definitely moving to the right. So that means most definitely you can do these things practically. Take any rope, you can take your charger, you can take your headset rope, any rope or any wire that you can use, any flexible wire that you can use. And then and at the other hand, make sure that it is fixed, it doesn't move at all. And then whip your wire only once. You're gonna propagate something that looks like this. Something that looks like this, what do we call that? we call it a pulse. Now, what is a transverse pulse? Now, transverse pulse is a definition that is a little bit more deeper than a pulse, but we need to understand it as well. Now, a transverse pulse is a pulse within which the displacement of the particles of the medium is perpendicular to the direction of the movement of the pulse. I have just said to you that a pulse is moving, and the pulse will be moving horizontally, meaning it will be moving to the right. But you have to understand that this is a rope, matter and materials. A rope has particles, right? So when you shank your rope only once, what's going to happen? I said a pulse is going to be formed. But we can see that the particles of rope, they will cause this rope to move upwards, right? To form a pulse. But we know that a pulse, it will be moving in this direction, which is to the right. And the particles of this rope, they are most definitely going to act perpendicular to the direction of the pulse. So the phenomenon that is taking place over here, we're going to call it a transverse pulse, a pulse within which the displacement of the particles, these are the displacement of the particles of the rope, of the medium, which is going to act perpendicular. In this case, the particles of the rope, they're going to act perpendicular, which is in 90 degrees to the direction of the movement of the pulse. It's also advisable for you to write down this definition and know the differences between a pulse and a transverse pulse. And these are the definitions of these words. Now, when you have a look on this slide, we have what you call the amplitude. Now, we are learning about the pulse now. We are learning about some of the characteristics of a pulse. In this picture, we also have what you call a pulse. But we never spoke about this displacement of the particles. We never spoke about this displacement from this point to that point. Now, this displacement from here to here, it's regarded to be a maximum displacement of the pulse. So this maximum displacement of the pulse is most definitely going to be called the amplitude of a pulse. But also the definition of an amplitude of a pulse is needed for your curriculum. Now, how do we define the amplitude? We say it is the maximum displacement of a particle from its position of rest or from its position from its equilibrium. So now when you talk about the equilibrium or when you talk about the position of rest, what is that? Now, when you have a look at your medium over here, it is linear. Also on this side, when you have a look at your medium at this point, it is linear. So remember, assume that this medium is a rope. So this position over here, it also, like I can also write the straight line to show it's continuing. So this position over here that is aligned to this line over here, it's called the position of rest. Okay, so what is an amplitude? A maximum displacement of particles from its position of rest, meaning it is this maximum from position of rest to the peak over there. So that's what we call the amplitude. So this is the amplitude of a pulse. Now let's talk about the pulse length. What is the length of, where do we see the length of this pulse over here? So from this point to the ending point, from the starting point to the ending point, this is the length, right? What is the length of this pulse? Is from there to there. But how do we define it? It is the distance between the start and end of a pulse. This will be the start of the pulse, and this point over here will be the end of the pulse. So this length over here represents the length of the whole pulse. Right. Now we spoke about the pulse. We defined the pulse. We defined the transverse pulse. We looked at some of the features of the pulse. How does the pulse actually look like? And what are those characteristics? The length of the pulse, the amplitude of the pulse. I said to you, a pulse, it is moving, right? So when you shank your rope only once, the pulse is going to be formed on that rope. and that pulse will most definitely attain a direction and it will move in a specific direction. But because it's moving, we know that the objects that are moving, they are most definitely moving with a certain speed. So we're still going to learn on how to calculate the speed of that pulse. The pulse is moving, we need to know how to calculate the speed of that pulse. Now in physics, the formula that we are most definitely going to use is V is equals to distance divided by change in time. Now this is the formula that we can use to calculate the speed of a moving pulse. Now let's talk about the units of these parameters. Now, the first parameter, which is called the velocity, the units that we are most definitely going to focus onto are in meters per second. These are the units for our velocity or our speed of a pulse. If speed is given in kilometers per hour, we need to convert that into meters per second. Now, to calculate the speed of a pulse, we're still gonna need what we call the distance. Now, the distance, the units that we're going to use are in meters. Okay, this is the distance of a pulse, a distance that a pulse will travel. So now, a distance that a pulse will travel, the units that we're going to use are in meters. Now, and then here we have change in time. Again, when your distance is given in different units other than meters, for an example, it's given in kilometers, in centimeters, in millimeters, we need to convert that into meters. And then here we have change in time. Change in time, the units for change in time, it's in seconds. When the time is given in hours, minutes, we convert that into seconds. So this is the formula that we are most definitely going to use when we are calculating the speed of a pulse. Now let's have a look at this problem, which is problem number 1. Now problem number 1, it reads as follows. They say to us, pulse travels a distance of 62 centimeters over 0.9 seconds. Calculate the speed of the pulse. So now we're most definitely going to write down the data that is actually provided from this statement. Now, the data provided in this statement, definitely we have the distance, right? They said our distance, it will be 62 centimeters. We are also provided with change in time. In this case, our change in time, it will be 0.9 seconds. But remember, we want to calculate the speed of the pulse. So meaning the speed of the pulse in this case, it is unknown. That's what we are looking for. This is the data provided to us. Now we know that based on this data, we have velocity, speed, we have time, and then we have the distance. The formula that we use is V is actually equals to D over change in time. Now, I said to you, the units that we use for distance, it's centimeters. And then the units that we use for time, it's seconds. So for time, we are happy because our units are in seconds. And then for distance, our units are in centimeters. That means we're going to have to convert that. Now, sometimes people tend to forget how to convert centimeters to meters. So now a trick or a quick trick that you can use, it's this. I know some they can call it different, some, it really does not matter. We say King Henry died miserable death cold. Normally this I'm not going to say malaria, but I'm going to say it's malaria so that I do not confuse these two M's over there. So here we have kilometers, hectometers, decameters, meters, decimeters, centimeters, and millimeters. So based on these units, you have to know this. Our exponents, it's 1, 1, 1, 1, 1. So when we move forward, we multiply by 10. What do I mean when I say when we move forward, we multiply by 10? From K to H, we multiply by 10. From M to D, we multiply by 10. From D to C, we also multiply by 10, meaning when you hop from one point to the other point, you multiply by 10, okay? But most definitely, if you want to move from kilometers to meters, you're going to have to hop how many times? Let's see. 1, first 10, 2, second 10, 3, third 10. So you're going to multiply by 3 tens from K to M. So that means 10 multiplied by 10 multiplied by 10, that will be 1,000. So that means if you want to move from what kilometers to what meters, you're going to have to multiply by 1,000, okay? So same analogy, it does work, but when we move backwards, we're going to have to divide by 10 from one point to the other point, okay? So now here we want to convert centimeters to meters. So that means we're going to have to hop how many times backwards? 1, 2. So this is 1 and 2. So this is 10. This is also 10. But because we are moving backwards, we are most definitely dividing. So that means we're going to use 2 tens, which is 100. So to convert from centimeter to meters, we're going to divide by 100. So that means our distance in this case, which is 62 centimeters, we're just going to have to divide that by 100. 100, it's 2 tens, right? And therefore, when we go to our calculator and you punch, it's going to be 0, 62 divide. I don't know why am I punching this on my calculator. I can just write it, which is 0, 0.62 meters now. Now we can use our formula that says V is equals to D over change in time. Now, in this case, our D, it will most definitely in meters be 0, 0.62 meters divided by our change in time, which is in seconds, which will be 0, 0.9 seconds. And therefore, our speed will be how much? Let's see. We get to 2 decimal places, we get 0, 0.69 meters, remember, per second. This will be our speed of this pulse. Now, problem number 2, it says to us, a pulse covered a speed of 0, 0.25 meters per second. Calculate the distance that the pulse will cover in 0, 0.5 minutes. So let us write data provided to us. Now, data provided to us is we are given the speed. Our speed is actually provided, which is in this case 0.25 meters per second. And we are also given time, which is change in t. In this case, our time, be careful, it's given in minutes, not in seconds. And then what do we want to calculate? The distance. So that means we want to calculate the distance. And again, still going to use the very same formula that we used to calculate the speed because that formula has distance. So what we need to do is to convert time. So now how to convert time? This is what we know. We know that 1 minute is actually equals to 60 seconds. This is what we know, right? But we want to know that 0, 0.5 minutes is actually equals to how many seconds? Because we need to convert these minutes into seconds. So we want to know 0, 0.5 minutes corresponds with how many seconds. So using this ratio, we can just only cross multiply. We can say 60 multiplied by 0, 0.5 and 1 multiplied by x. So when we say 60 multiplied by 0, 0.5, we actually get 30. And therefore, 1 minute multiplied by x will be x. So in this case, we're going to get 30 seconds. So that means our change in time, which is in minutes, will correspond with 30 seconds. So let us write the formula. We know that the formula is V is equals to D over change in time. But now we want to calculate the distance. So we're going to have to make the distance subject of the formula. This V is the same as V over 1, right? So I'm going to cross multiply. I'm going to say D multiplied by 1. It will give me D. And I'm going to say V multiply by change in time. I cross multiplied. And therefore now my D, it is the subject of the formula, which is what I'm looking for, the distance. Now what will be the speed of the pulse? In this case, they said our speed is 0.25. Close my bracket and open my bracket for time. In this case, our time will be in 30 seconds. And therefore, when we punch this on our calculator, we actually get 7.5 meters. Remember, we are now calculating distance, and therefore this will be our units. I hope this problem is clear on how to calculate the speed covered by a pulse. Now let's have a look at these questions. Now they say to us these are multiple choice questions and we need to choose only the correct options. Okay. Now a transverse pulse is, we need to know what is a transverse pulse. When you started, we spoke about the definition of a transverse pulse. So you can pause this video and try to answer these questions by yourself and then play it later on. So welcome back if you pause the video. So now, number one, it says a transverse pulse is, let's start to choose the correct option here. A transverse pulse is a single disturbance. No, a transverse pulse, it is not a single disturbance. A pulse, it is a single disturbance, not a transverse pulse. We have learned that, right? Now, the option A is totally out. Now, a transverse pulse is a single vibration. No. A transverse pulse is not only a single vibration. Now, when you talk about a vibration, we are talking about when you move your medium vigorously up and down, or maybe just once, and therefore the particles are going to vibrate in your medium. Okay, that's what we mean when you talk about a vibration of the medium. So we cannot say a transverse pulse is just a vibration, no. But number C, it says a transverse pulse. Transverse pulse is both A and B. It is actually true, meaning in this case, the correct answer will be option number C. Why? Because a transverse pulse is vibration and a single disturbance, and this vibration will cause the particles of medium to act perpendicular to the movement of the pulse. Okay, so the correct option over here, it will be C, and therefore this will most definitely be out. Now let's move to question number 2. In a transverse pulse, the direction of the distance is always, we need to know that in a transverse pulse, the direction of the disturbance, remember the disturbance is most definitely talking about the vibrations. The direction of the disturbance is always in the same direction as the direction of the propagation. No, this is totally out. It can't be in the same direction. In the opposite, oh my god, this is almost totally out. In the opposite direction of the direction of the propagation, nope, it can be in opposite direction. Number 1, the transverse pulse, the direction of the disturbance, it cannot act parallel or anti-parallel to the propagation of a pulse. Okay, when you propagate a pulse on a medium, we know it will move horizontally, but we know where the particles are going to move. The particles are going to move upwards, while the pulse will move to the other direction, which is horizontal. So they're going to act perpendicular. So this is parallel. They are not moving in the same direction. Parallel to the direction, no, no, no. This is totally out. Perpendicular to the direction of the propagation, yes, this is the correct option. The transverse pulse, in a transverse pulse, the direction of the disturbance is always perpendicular to the direction of the propagation. This is the correct answer over here. Now, number 3, the amplitude of the pulse is there. What is the amplitude of the pulse? We have learned that, right? Number A, the maximum displacement of the particles from the, oh my God, this is absolutely correct. We don't even have to go down. This is most definitely absolutely correct. And you can go through these. These are most definitely not correct, not correct answers. So our correct answers is C, D, and A. Now, let's talk about the interference. When you talk about the interference, what are we actually talking about? Do you know that when, let's say, maybe you are having a conversation with someone and the third person comes and intervene or interfere your communication, we say that person interferes in the communication of two. So, interference in this case, this is how it works. So we have learned a pulse, right? And we have seen a pulse and we know how a pulse actually looks like. Now here we're going to talk about two pulses that are going to interfere with one another. So two pulses can be formed in one medium. Let me give you a quick scenario how two pulses can be formed in one medium. We have learned about only one pulse. We never looked at two pulses getting formed in one string. So let's say this is you, right? This is most definitely you, and there are your hands, and then you have a rope in your hand. And let's say on the other end, there is a friend, right? Your friend is also holding a rope. Now, this is a medium, right? And now let's say you shank this rope from upward and downward. And then your friend does the same thing, but your friend in this case, let's say maybe he shanked the rope up downwards and upward. So now what's going to happen is this is the result that's going to take place when you do that. This is the rope, right? You shanked it only once and then you manage to form a pulse in this way, and then there will be your friend, and then your friend will manage to form a pulse most definitely um in that way. Okay, so you shank a rope once, a single disturbance only once, moving up and down, and then this is what is going to be formed on the rope. And then your friend, on the other hand, he moves the rope down and up, and therefore this is what it is actually going to result. And remember, this pulse, it will after this single disturbance, this pulse will move to the right, and then the particles of the particles of this medium will act perpendicular to the direction of the pulse. And then this pulse over here that was propagated by your friend will move towards you, right? Now, this is what is going to happen. When this pulse moves towards you and this pulse moves towards your friend, maybe at this point, somewhere around here, when these two pulses meet each other at this point, they're gonna interfere with one another. That's what we call the interference. Interference will take place when these two pulses actually meet with one another. So what is the division of the interference? The overlapping of two pulses that are at the same point at the same time, meaning this is a point at which this pulse and this pulse are going to meet at. So we can see that in this diagram, it just explains what I just told you over here, whereby this red pulse and this blue pulse, they're gonna interfere each other at this point. Now the red pulse, it is now dead. The blue pulse, it is also now dead. Now we have the green color. What does the green color mean? The green color is a resulting of combination of these two pulses. But you will see how that actually works because we have two types of interferences. So that's what we mean by interference. Now, what is superposition? So when you talk about the superposition, we are actually talking about the sum of the amplitudes of the two pulses when they interact with each other. Look, this pulse is moving to the right. This pulse is moving to the left. I said to you, when they meet each other at this point during the interference, what's going to happen with the amplitude of this pulse and the amplitude of this pulse? They're going to add to one another. So That phenomenon whereby the amplitude and the amplitude of this pulse, as they meet at this point, we call it the superposition, where it's the sum, which is addition of the amplitude of two pulses when they interact with each other. Okay, that's what you call superposition. Now, like I said, there are two types of interferences. The first one is called constructive, and the second one, it is called the destructive. So when you talk about constructive, it's when you construct, right? It's when we build. But when you talk about the destructive, it's when we destruct, it's when we destroy, actually. Okay? Now, let's have a look at this type of interference, which is called constructive. How do we define this? We say when two pulses meet each other on the same, this is a key word, on the same side of the rest position. And then when these two pulses meet each other on the same side of the rest position, results in a pulse with a larger amplitude. Now, this superposition, I get it, but you have to understand that we're going to have two pulses that are going to meet each other on the same side. So when two pulses are meeting each other on the same side, during superposition, what's going to happen with the resulting pulse? The resulting pulse, which is combination of pulse A and pulse B, they're going to give a larger amplitude. But we'll look at the pictures after this definition. Now, let's talk about the destructive. Now, when two pulses meet each other again, now this is opposite, it is no longer the same. So destructive, it's when two pulses meet each other on opposite sides of the rest position, result in a pulse with a smaller amplitude. So when you talk about destructive, it's when the other pulse, what I have just explained over here, it's an example, it's what type of interference. It's destructive because this pulse, remember, this is a rest position, right? This pulse is on that side of the rest position, and this pulse is at the below of the rest position. So this pulse, they're going to meet each other at this point. Now, this type of interference is called destructive interference because they are in opposite sides of the rest position, which is what we have just read over here. Now, let's have a look at the clear pictures. What is a constructive interference? Like I said, we said when two pulses meet each other on the same side, we can see that we have pulse A and pulse B, and they are moving in opposite directions, but they're gonna meet each other at this point. And then when they meet each other at this point, remember what did we say? Results in a pulse with a larger amplitude. We can see that pulse A and pulse B, we're gonna add their amplitude. Amplitude of pulse A plus amplitude of pulse B, gonna say A plus B, is gonna be greater now because this type of interference is called constructive, which the pulses are in the same direction. Now, the reason why we add them, it's because they are in the same direction. They can also be at the bottom. Even if they are bottom, we're still gonna add them. So this is before interference, this is during interference. Now, after these two pulses meet, at some point, these pulses, they're gonna separate with one another, right? I get it. Pulse A, it was coming in this direction. So it needs to move or to continue to move in the very same direction. So after the interference, the pulse A will most definitely continue with its motion to the right, and pulse B will most definitely does also continue in the direction at which it was moving at after interference. But during interference, they're gonna combine and then it moves again to continue. This is constructive interference. Now let's have a look at the destructive interference. Now we have two pulses again, but you can see that this pulse, it's at the top of the rest position. This pulse is at the bottom of the rest position, and they are moving towards each other. At some point, they're going to have to meet, just like these two pulses as they met. So even these two pulses, at some point, they're going to have to meet. But the thing is, this pulse, it is upward. It has a maximum value which is on this side, on opposite direction, on opposite sides. So this one, it also has a magnitude value, the amplitude magnitude which is on this side. Now here's the thing. This pulse will have a maximum positive value, and then this pulse will have a maximum negative value of an amplitude. So positive plus negative, when we add those two numbers, what's going to happen? They're going to destroy each other. Probably they might even give us zero. Like for an example, the pulse of A and the pulse of B, they are equal in magnitude. If here it's 2, for example, let's say here we have 2 meters, and then there we also have 2 meters. But you're going to have to understand that this 2 meters is positive, this 2 meters is negative. So when we add them, 2 plus negative 2, they will give us 0. Hence why during the interference, there will be no formation of an amplitude. And then remember, after the interference, what's going to happen? Pulse B will continue in the same direction at which it was moving, and then pulse A will does same thing to continue in the same direction at which it was moving. And you have to be careful that in this case, these two pulses, in this case, it's an interaction of two pulses in one medium.